Hello students, in previous video uh, we had question 1 and 2 of assignment 7.1. Now in this video we will address third question of this assignment. The question is write expression for complex current for AC circuit with capacitor only. Actually we will be deriving this. So let us start with AC circuit and see how to find out current for AC circuit. So consider a capacitor with capacitance C connected to a source of alternating voltage. So if voltage is V, let us say Vm sine omega t. Again, I would like to mention that not necessary it is always function of sine. It can be function of cos also. So if it is function of sine, how do I represent voltage on V versus t graph? On horizontal axis, you can take angle also, phase also, and time also. Nature will not change. So for function of sine, voltage should be changing in this manner. And what is this value? This is the maximum value of voltage, which can be Vm. So this is how we can represent voltage. And now I want to find out that how much is the current in this circuit. Now, as explained earlier, if it is DC source, then there will not be any current because capacitor is combination of two plates, two conductors separated by some distance. So charge cannot flow in one direction. With DC source, it will simply charge the capacitor. But with AC source, polarity at these two ends will continuously be changing. Okay, and so there is continuous sweeping of polarities, and then the capacitor is continuously charging and discharging, and hence you have flow of charge in the circuit, which we which we regard as current. So how do I find out current in the AC circuit with capacitor only? So as capacitor is not ohmic component, it is not obeying Ohm's law. So we cannot write V is equal to IR as if there is no R here. How do I find out current value here? So for that, let us use what our knowledge about capacitor. We know that V is equal to Q by C. So if charge deposited on capacitor is Q and if capacitance is C, then we can say that V is equal to Q by C. Okay. Because C is equal to Q by V. Earlier in definition of capacitor we had that equation. So let us try to employ that here and see if it can help us finding out current. Let it be equation 1. Now we know that I is equal to dq by dt. Let me label it as small I. So I should be able to write dq as I dt, and integrating both sides, integration of dq will give me q. So integration I dt, let this be the second equation. So now I can write first equation as Vc is equal to integration I dt, isn't it? So now if I want to make I subject of formula, I'll have to differentiate both sides. Then my right hand side, first let me rearrange these terms. So I dt is equal to V into C, and to get I differentiate both sides, and then we get I is equal to d by dt of V into C. Now C is capacitance of the capacitor, it is constant, we don't need to worry about that, but V is time dependent quantity. V is equal to Vm cos or sine omega t. For now it is sine omega t. So again Vm is constant, I can take it out. So Vm into C. What is the differentiation of sine? So differentiation of sine omega t will give us cos omega t. Okay, and as it is being differentiated with respect to t, with respect to time, omega will also be there. So Vm into c, and then I'll have omega cos omega t. So current is Vm omega c into cos omega t. I should be able to write this as Vm upon 1 by omega c cos omega t. Now why to make it more complex? Because we know that 1 by omega c is xc, isn't it? So you can write Vm by xc cos omega t. This is the expression of current for circuit with capacitor only, AC circuit with capacitor only. Nothing wrong in writing this current in this way. Okay, both are possible ways of expression. And again, as Xc and Vm both are constant, uh, it's okay if you denote it as Im. So Im cos omega t, but don't forget that Im is Vm by Xc here. So now, if I try to represent it, this equation, let me rewrite the two here. V is Vm sine omega t, and I is Im cos omega t. So what is the phase term indicating? Phase term is indicating that both are varying at same speed omega, but voltage is function of sine, current is function of cos. So when voltage arrives at its peak, current will be at 0. So the variation in current can be shown as see, I have to be careful. When voltage is maximum, current should be made 0, because when sine 0 when you take, sine 0 is 0, cos 0 is 1. Okay, similarly, when sine 90 is 1, cos 90 is 0. So be careful. When voltage is 0, current reaches its peak. So peak of current should be shown somewhere here. Again, when voltage is maximum, that is at this time, current should be made 0 exactly at that time. Again, when voltage is 0, current should be reaching its peak value. Okay, and so on. So why did I show current peak at higher value? The reason is, if you look at the Im value, this Im is Vm by 1 by omega c. So actually it is Vm into omega c. So it is possible that Im is greater than Vm. Now, both possibilities you may consider. Vm may be greater than Im, or Vm may be less than Im. Both are possible situations. So where is the peak is not very important, or it cannot be factual accuracy or inaccuracy. You just have to mention which condition you are talking about. So this is what you are supposed to remember in this topic, that for capacitive circuit, if voltage is function of sine, current is function of cos. If voltage is function of cos, current will be function of sine. And what other thing? Im, maximum value of current, is Vm by Xc. That is all for now. Thank you.